All right, so in this video, we're going to go through sample question 88 from the Society of Actuaries ExamP list of sample questions. The question reads, the waiting time for the first claim from a good driver and the waiting time for the first claim from a bad driver are independent and follow exponential distributions with mean 6 years and 3 years respectively. Calculate the probability that the first claim from a good driver will be filed within 3 years and the first claim from a bad driver will be filed within 2 years. All right, so let's say G refers to the first claim from a good driver and B is a random variable for the first claim for a bad driver. Okay, so G is exponentially distributed, right? It's exponentially distributed with mean of theta equal to 6. And a bad driver, exponentially distributed with a mean equal to 3. What we're looking for is the following: the probability of a claim made by a good driver being filled within 3 years, so less than or equal to 3, and the claim made by a bad driver being filled within 2 years, so less than or equal to 2. So what we're going to need to find is the CDF for each of these random variables. The reason why is the CDF is obviously the probability that an event happens at a value less than or equal to some value. So the probability of G occurring less than or equal to 3, well, that's exponentially distributed. We need to memorize these random variable, these certain distributions. The exponential distribution is one of those. So the CDF for an exponential distribution is as follows. I'll actually write that here as in a different color. Now, there are plenty of equation sheets online. I recommend the one by Coaching Actuaries. I believe theirs is free. You don't even need anything. There we go. 1 minus e to the negative x over theta. So it's going to be 1 minus e to the negative x, x being 3, divided by theta. In this case, theta is 3. Theta is 6. I was looking at the wrong one. We're working with G. I'll kind of rewrite this down here. 1 minus e raised to the negative 3 over 6, which is 1/2. Next, the probability that B is less than or equal to 2. Going to follow the same thing. It's 1 minus e raised to the negative, and it's going to be 2 over 6. Or 3. I keep making that mistake. I keep looking at the wrong one. Minus e raised to, actually it simplifies to 2 over 3. Great. Now we're looking for this probability. Here's the key. Boop. We're told these things are independent. So I can rewrite this as the probability of G being less than or equal to 3 multiplied by the probability of B being less than or equal to 2. Great. Now all I have to do is just multiply these. 1 minus e raised to the negative 1 over 2 times 1 minus e raised to the negative 2 over 3. Okay, now at this point, you're just going to see me do some algebra. And 1 times 1 is 1. 1 times negative e to the negative 2 over 3 is negative e to the negative 2 over 3. Negative e to the negative 1/2 times 1 is negative e to the negative 1/2. And then finally, negative e to the negative 1/2 times negative e to the negative 2 over 3 is simply just those two added together. And I'm just going to double check so I don't end up making a really dumb looking mistake. Negative 1/2 plus negative 2/3. And I get negative 7/6. So this becomes e to the negative 7/6. And I multiplied this out because clearly there's no like two-factored answer choice. So the one that follows this answer choice looks to be answer choice C. It's the only one that contains all 4 of the items listed here. Okay, so overall a pretty simple question, just I suppose a really quick review. The question first asked for the probability of 2 different things, right? We have 2 random variables and we're looking for the probability that this first random variable is less than or equal to 3 and the probability that the second random variable is less than or equal to 2. We're looking for the intersection of those 2 items. And from there, I have to recognize, okay, each item is exponentially distributed. I can find the CDF of that because that's what this is. You have to recognize when you're looking at a question that needs to use the CDF. And finding the CDF for each, pretty simple. That's a memorized formula. Next, understanding these are independent, right, like stated in the question. You can write an intersection as a product of each individual item. And then it's just some algebra. All right, if there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That very much helps me out. And if you want to see some more ExamP sample questions, I have a playlist, more and more being added as we speak, and eventually hopefully being done. So check that out. But other than that, I hope this helped. Good luck.